Okay, let's do a little VXLAN lab. First of all, we are going to create a normal, regular, traditional VLAN. In this case, we are going to create VLAN 10 here, VLAN 10 here. We are going to configure this port and this port as access ports for VLAN 10 in such a way that these two devices should belong to the same broadcast domain. Then we are going to configure an underlay protocol. In this case, we are going to use EIGRP as our traditional IP routing protocol that will perform the functions of underlay. It is going to be configured here, here, and here, and we are going to use it in order to advertise the loopback interface IP addresses of these three devices. Then we are going to configure our overlay control plane that is going to be actually multicast. We are going to configure PIM sparse mode, and we are going to configure it here, here, and here. This spine device will perform the functions of rendezvous point for our multicast network. And finally, we are going to configure our overlay data plane protocol that will be VXLAN in such a way that this LIV4 device is going to become a VTEP for VXLAN. This LIV3 device is going to become a VTEP for VXLAN. We are going to configure the network virtual edge interfaces. Remember that we can only configure one of these interfaces per device. And then we are going to configure at each VTEP a mapping. We are going to map VLAN 10 to the VNID 10, 10, 10. And under this configuration, under the network virtual edge interface, we are going to map the VNID 10, 10, 10 to the multicast group 239.10.10.10. So we need that because remember that multicast in this case is going to simulate bomb traffic. So the ARP requests are going to be transported through multicast. So let's do the lab. Let's start with regular configuration. We already know how to do this. We are just going to create VLAN 10, and then we are going to associate interface Ethernet 1, 2 to this VLAN number 10 as an access port. Okay, let's configure now the underlay. So we need the EIGRP feature turned on. So let's turn it on all devices. And then we are going to configure EIGRP in order to advertise the interconnections and loopbacks. We are going to use the command network 10.0.0.0. So we are going to include everything that starts with 10. That will include the interconnections and the loopbacks. So after that, we can see that we have our neighbors up, and we have our IP table. And actually, we're talking about the global routing table. We have the loopbacks, for instance, and loopback for LIV3 is 10.3.1.3, and for LIV4 is 4. The same way we can ping the loopback for the spine, which is 10.3.1.1. So far so good for the underlay protocol. Now let's configure the overlay control plane. We are going to need PIM, so we are going to enable the PIM feature. Remember that we are working with Nexus. We need to enable these features individually. So for the spine, we are going to enable itself as the rendezvous point, and we are going to enable PIM on these interconnections through the leaves and in the loopback. Let's do the same for the leaf switches. We are going to configure the rendezvous point. This will be the spine switch, and we are going to enable PIM on the interconnections and in the loopback. So we should have show IP PIM neighbors. So the spine already see these two devices as neighbors, which are the leaf switches. Let's configure now VXLAN. So we have a couple of features. This feature will let me create an NVE. This feature will let me create this mapping. So we are configuring this BTEP with this source interface IP address, and we are mapping VLAN 10 to VNI 10.10.10, and then we're mapping the VNI 10.10.10 to the multicast group 239.10.10.10. Let's do the same here, and we have a capture in place. Let's do a ping between PCs. So let's ping the PC that is on the other end. Now we can see that there is a broadcast going on here where we are asking for a particular ARP request that is encapsulated within VXLAN, and then after that is successful, we are sending the ping. This is an ICMP packet that is encapsulated, that is traveling actually within an Ethernet frame, and this Ethernet frame is encapsulated within a VXLAN packet. We have the IP header that goes from a VTEP to VTEP. We have the UDP header with destination 44789 and the VXLAN header. We can see that this frame corresponds to the VNI 10.10.10.